Hello and welcome everyone. Very happy that we're all together again. In this tutorial, we will start talking about the low voltage distribution system components and how they are connected to each other. So fasten your belt and let's get started. The aim of this tutorial is to know what are the different components used in the distribution system and how they are handled with each other. And this is by taking a general overview on them, so we don't need to go in details on each electrical component of the low voltage distribution components, but we just need to know how the different parts of the distribution system are handled with each other. So let's go ahead. Here we can say that this is a simple example of the distribution system which contains the required basic components. Here the first component of the low voltage distribution system is the load break switch, which is the input of the transformer. As you see, the transformer has an input and it has an output. So the input of the transformer is the medium voltage side, as the transformer may convert from 11 kilovolts or 22 kilovolts to 400 volts. Hence, the load break switch is the input of the transformer at the medium voltage side. And this load break switch is just a three-phase switch which can operate manually to be turned on or off, as if we make the load break switch to be on, it will connect the power to the transformer at the medium voltage side. So the transformer will be connected to the medium voltage power in case of we made the load break switch at the on state. Also, we can make the load break switch at the off state. And at that condition, it will cut the power from the transformer, so the transformer will have no input power at the off state. So that's the idea of the load break switch, which is to close the circuit or open it manually, as it's a manual switch, not an automatic one. After that, the second component we have is the transformer, and the job of the transformer is to convert the input power from the medium voltage level to the low voltage level, as the electrical loads works at a voltage rating equals the low voltage level. Hence, we use this transformer to decrease the input power from about 11 or 22 kilovolts to only 400 volts. After that, the next component we have is the main distribution panel, and this distribution panels contains some circuit breakers inside it, and the job of the circuit breaker is to close or open the circuit at the low voltage side. So if the load break switch is used to close or open the circuit at the medium voltage side, here the circuit breaker is used to open or close the circuit at the low voltage side. But the circuit breaker is used also as a protection element, as it breaks the circuit automatically at the short circuit condition. Hence, we say that this main distribution panel contains some circuit breakers. The first one is the incoming circuit breaker, which is connected to the transformer output directly. And the second one is the outgoings, which are some group of circuit breakers which are connected to the different electrical loads in the system. So we say that the main distribution panel consists of the ingoing main circuit breaker and the outgoing branches of the circuit breaker. And after the main distribution panel, we have the electrical cables, which connects the main distribution panel with the sub-main distribution panels. And we use those electrical cables because the main distribution panel may be far from the sub-main distribution panel, so we need an electrical cable as a link between the main distribution panel and the sub-main distribution panel. As the main distribution panel may lay at the ground floor, while the sub-main distribution panel may lay at the third floor, so we need a cable to link between the main distribution panel and the sub-main distribution panels. And this cable at that case is called the riser, and from its name it rises from the lower floor, which has the main distribution panel, to the upper floor, which has the sub-main distribution panel. Very good. After that, we have the sub-main distribution panel, and this sub-main distribution panel is used to feed some electrical loads directly. So it takes its input from the main distribution panel and it distributes its outputs to the electrical loads directly. And the sub-main distribution panel consists also of some circuit breakers. The first one is the ingoing circuit breaker, which is connected to the outgoing breaker of the main distribution panel, and also we have some outgoings, which are some circuit breakers connected to the electrical loads directly. But you can ask now, why we don't connect the electrical loads directly from the main distribution panel, or why we use a sub-main distribution panel after the main distribution panel? Here we say that the number of the electrical loads in the building is very large, so there will be no just one panel, which is capable of having the required size to contain all of the number of circuit breakers to be installed on it for all of the electrical loads at one time. For example, if we have 200 loads in our building, there will be no distribution panel that has 200 outgoings. Hence, we have some sub-main distribution panels which take its input from the main distribution panel and they distribute their output to the electrical loads. And an example of that, if we have a building consists of 3 floors, at that case we will have the main distribution panel which feeds 3 sub-main distribution panels, as each floor of those floors will have a panel or will have a sub-main distribution panel installed on it. So each sub-main distribution panel is responsible for feeding all the loads laid in that floor of the 3 floors. And the loads at the sub-main distribution panel can have a variety of its type. For example, one output of the sub-main distribution panel can be a lighting luminaire like that one, so there will be one line or one outgoing which is responsible for feeding those luminaires, and this outgoing consists of the circuit breaker, and we go out of the circuit breaker with the line and neutral, which are connected directly to the load or the luminaires which we will feed. So this yellow wire here is connected to the circuit breaker from one side, and it's connected to the electrical loads or to the lamps in the other side. But for the neutral or for this black wire, it's connected directly to the luminaires from the other side. And for the line and the neutral wires, they are not going freely to the loads or the luminaires, but they are going through some conduits like that one. This is because the luminaires are installed on the ceiling of the room, and this ceiling may be a concrete ceiling or a suspended ceiling, so the wires cannot go freely with no body to include them. Hence, we insert those wires inside some electrical tubes, which is called the conduit. And finally, they are connected to the luminaires through those conduits. And by that way, the electrical power is going to any electrical load, which may be some luminaires on the ceiling, like that case here. So we can summarize the distribution system in that way. Firstly, we have the medium voltage side, which we connect it or disconnect it using the load break switch. Then we have the distribution transformer, which takes its input from the medium voltage side at the load break switch. After that, the transformer distributes its electrical power to the main distribution panel, which has an incoming circuit breaker and some outgoing circuit breakers. And those 3 components, which are the load break switch, the transformer, and the main distribution panel, lays in one package, which is the electric cossack. So the electric cossack contains the load break switch, the transformer, and the main distribution panel. After that, the outgoing of the main distribution panel will be connected to the sub-main distribution panels through some cables. Hence, the cables links between the main distribution panel and the sub-main distribution panel. And after that, the sub-main distribution panel will have some outgoing circuit breakers, and we go out of those circuit breakers with some wires, and those wires go inside some conduits to the electrical loads directly, which may be some luminaires like that case. Alright, now we can focus on this sub-main DP to know how it distributes the electrical power to the loads. Here we say that if this is the sub-main distribution panel, we can go out of it with one line which contains or which consists a wire coming out of the circuit breaker, and also we have the neutral wire coming to it. And those two wires are passing through the conduit like that one. Then for the line and neutral, which are feeding the loads, which may be some luminaires, this conduit is moving inside the ceiling, so it's moving inside the walls or inside the ceiling, and then it's connected to the electrical switch, which will control the lamp to be turned on or turned off, and after that it returns back to the luminaire on the ceiling to feed it. So that's for the lighting load supplying system. Also, we can represent this system in some details. Suppose we have this sub-main distribution panel which inserted at that position of the corridor. Here we can go out of it with some wires that are inserted in some conduits, and those conduits lays inside the wall, not outside it or not on the surface of the wall, but it lays embedded inside the wall. And here we go up until reaching this box, which is called the junction box, and we will talk about the junction box later in details. But for now, this junction box is used to distribute the wires, as some wires will go out of it through another conduit, and some wires will go out of it through another conduit. And for the wires which will feed the lighting luminaire, they will go through this conduit, and hence we will have a line and neutral going through this conduit. And for the neutral wire, it's connected directly to the luminaire, while for the line, it will go to the switch firstly. This is for the controlling switch to turn on or turn off the luminaires, so we control the luminaires using this switch. Hence, the switch will cut the line, then the line will go back to the luminaire to feed it. And all the lamps will be connected in parallel through that way for the switch to control them. More than great. So that's about a general overview on the different components of the distribution system. Hope that's clear right now. Thank you for watching and see you next tutorials. Hello and welcome everyone. Very happy that we are all together again. In this tutorial we will talk about an important element used in the distribution system, which is the junction box. So fasten your belt and let's get started. The aim of this tutorial is to learn what are the junction boxes and what are their different types, to know how can we use it in the distribution system and how can we get the most benefit of it. So let's go ahead. We will start now with the point which we ended with in the previous tutorial. If you remember, we said before that this is the junction box, which links between the distribution panel and the electrical loads which we will feed with some wires. So the junction box is a box which is embedded inside the wall, or it's hidden inside the wall. And the electrical wires are passing through this conduit. Hence, it has an input conduit like that one, which has the inputs wire passing through it. And it has some output conduits like those ones through which the electrical wires are going out of the box. And all of this system lays inside the wall, or it's hidden inside the wall in case of a concrete building like that case here. Now the important question is that, what are the different types of those junction boxes, or what are the different kinds of junction boxes we can use in the distribution system? Here we say that the first type of the junction boxes is the plastic junction box, or the junction box which is made of the PVC material, which is the polyvinyl chloride. And this is one shape of the plastic junction box or the PVC box. As you see, it has a base which is installed inside the wall, and it has a cover like that one. And there are some circular holes, and they are used for the wires to enter them and for the wires that is going out of the junction box. So there will be a conduit entering this junction box coming from the distribution panel, and there will be a conduit or some conduits leaving this box going to the electrical loads. Also, this is another shape of the plastic junction box. As you see, it has some holes for the cables entering it and for the cables leaving it. And this plastic junction box is used in places where there is less mechanical stresses, as the plastic material is not a strong one, so it will not withstand the higher mechanical stresses which may be applied to it, or it cannot withstand the high mechanical shocks for anybody that may hit it so it may be broken. And for that purpose we use this plastic type of the junction box in places like the hospitals, the schools, and the administrative buildings where less mechanical stresses are applied. Also, this type of junction boxes is embedded inside the wall, so what appears only is the surface of the box. And the third property of this plastic junction box is that it's a cheap one, and this is because it's made of plastic, so it doesn't cost much. Very good. And also, this is the shape of the junction box and the real design. You can see it's embedded on the wall, and what appears from it only is just its surface. And this is another shape of the actual junction box after the installation process. So that's for the plastic type junction box. Very good. Now the second type of junction boxes we have is the metal type junction box. And for that type of boxes, it has a shape like that one. You can see it looks like the plastic box, as it has some holes for the entering wires and some holes for the outgoing wires. And also this is another shape of the metal junction box, and it's used in places where there is high mechanical stresses like factories or on the stairs of any building, as in those places there may be some mechanical shocks that are applied to the box due to any shock or due to any accident. Hence we use the metallic type in those applications as they withstand those shocks. Also, this type of boxes is exposed to the wall, so it's not embedded totally inside the wall, but there is a part of this box which is exposed out of the wall. And its third property is that it's an expensive box. This is because it's made of metal, and the metal is expensive when compared to the plastic. Hence we say that the metal junction box is expensive compared to the plastic junction boxes. Alright. Now the important question is that, where we can use the junction boxes, or where can we decide that we need a junction box? Here we say that the junction boxes are used in places where there is a concrete ceiling, and we don't use the junction boxes in places where there is a suspended ceiling. This is because if there is a suspended ceiling, or the junction required for the wires of the distribution of the electrical power will be installed above the suspended ceiling, hence there is no need for a junction box on the wall, as there is a suitable area above the suspended ceiling to install all of the required connections. Alright, now we need to know what are the different usage of the junction boxes, or in which applications we are using the junction box. Here we say that we use the junction box in two different usages. The first one is to be a distribution and connection box, and at that usage, this box is used to connect the wires through it from the distribution panel to the electrical loads, and it distributes those wires from the distribution panel to the electrical loads. For example, if this is a distribution panel and this is the junction box, we will go out of the panel with the main conduit that has all the required wires inside it, and then those wires will enter the junction box, and at that point there will be some wires that are connected to one side, and it leaves the junction box at a group of loads through one conduit, so it will feed some kinds of loads through this conduit, and another group of wires will be connected to some other wires, and it will go through some other kinds of loads through one conduit to feed them, and a third group of wires will be connected to a third group of loads. So this is the usage of the connection and distribution box. And we can see here this is a layout for the distribution system that has some junction boxes. Suppose this is a plan for a floor which we need to distribute the electrical power to it, and suppose this is the sub-main distribution panel, so it's installed in that place, and suppose also those are two rooms that we need to feed them with the required electrical power. Here we will go out of the sub-main distribution panel with a conduit that passes in the ceiling through that path, so this will be the main conduit which has the electrical wires inside it. Now we will enter each room through a junction box. Hence this junction box works as intermediate between the loads and the incoming power. Then we will go out of this box with some other conduits that are feeding the loads we have. Here one line and neutral inside one conduit going to the electrical sockets, and another conduit that has another line and neutral going through the luminaires we have. So we don't go directly from the distribution panel to the loads, but we have an intermediate junction box. And by the same way, we go out of the second connection and distribution box with some other wires as you see, and they are going through the conduit to the other types of loads. Alright. Also, the important note here is that we can have more than one junction box, as it's not a requirement to use only one junction box in each room, as we can use more than one box, and this is in case of the room has a larger area. So if we have a room that has a larger area, we can install more than one junction box at which. Very good. So that's for the first usage of the junction box, which is for connection and distribution. Now the second usage of the junction box is to be a pulley box. And the pulley box is used as an intermediate between the distribution panel and the electrical loads. So in that case, there are some wires that are entering the box and leave the box at the same arrangement with no change. Or in other words, we are not distributing the wires at that case. Just the wires pass through the pulley box, or the pulley box is cutting the wires from the distribution panel to the loads. And in that case, we use the pulley box as a support for the wires, or as a point at which we can make an inspection for the wires. So suppose that there is a problem at the wires which are passing through the wall, and we need a point at which we can inspect those wires or make a troubleshooting for those wires. So this pulley box is the point at which we can troubleshoot the wires, as the wires appears from the box when we open it. Also, we use the pulley box if we have a long distance between the distribution panel and the electrical loads, as at that case we cannot push the wires through the conduit directly, as there is a long distance between the source and the loads. So if the distance between the distribution panel and the loads is larger than 15 meters, at that case we put a pulley box. Or in other words, each 15 meters we insert a pulley box. And it's used as a support for the wires, or as a point at which we can pull the wires from it. So we handle the wires from this pulley box after each 15 meters of passing the wires from the conduit inside the walls. But you know, this pulley box is not installed each 15 meters only, but we insert a pulley box after a distance which can be less than 15 meters. This is in case of there are some pins on the conduits passing through the wall. This is because the wires at that case are not going directly in a straight way, but it may have some pins during its path. And in that case, we install the pulley box after each 2 pins of the conduit. So after each 2 pins and the conduit, we install a pulley box. Hence, we can conclude that the pulley box can be used as an inspection point for the wires, or as a support point for the wires to be easily installed or pulled through the conduit. More than great. So that's about this tutorial at which we installed the usage of the junction boxes. Hope that's clear right now. Thank you for watching and see you in next tutorials. Hello and welcome everyone. Very happy that we are all together again. In this tutorial, we will talk about the electrical conduits, which are the wires passing through. So fasten your belt and let's get started. The aim of this tutorial is to know what are the different types of the conduits which are used in the electrical distribution system, and we will learn how to select the suitable conduit system. So let's go ahead. First of all, to know what are the electrical conduits and why we need them, we say that the conduits are some kinds of tubes that the electrical wires are going through. This is because the electrical wires cannot go freely in the air to feed the electrical loads, but the wires are passing through those conduits for the conduits to protect the wire from any damage or from any cut. So the conduit represents the cover or the passage that the electrical wires are going through. And those conduits can be installed in many places, not only one place. So they can be installed on the concrete ceiling as you see. And this is also another figure for the ceiling that the conduit are installing on. Here this is the armored steel and the concrete will be spread on it. And also the conduit can be installed on the wall itself, not only on the ceiling. Very good. But we need now to know what are the different kinds of those electrical conduits. Here we say that the first type of the conduit is the metallic tubing conduit, and this type of conduits is made of metal, and we use this tube or conduit in case of the conduits are exposed outside the wall or are exposed outside the ceiling. So in case of the outside conduits, we use the metallic tubing type. Now the second type we have is the flexible metal tubing, and this type now is made of metal, but at that time it's not a rigid one like the previous type, but it's a flexible type of the conduit, which means that it can be used on the pins or on the curvature passes. This is because it's a flexible one. And also this type of conduit is used in case of the outside installation of the conduit, or if the conduit are installed outside the wall or outside the ceiling. So that's for the flexible conduit. Now the third type of conduits we have is the rigid PVC conduit, and this type is made of the rigid plastic or the rigid polyvinyl chloride. So it's made of plastic, but it's a rigid plastic or a non-flexible one. And this type of conduits is used in case of the conduits are hidden or impeded inside the wall or inside the ceiling or inside the suspended ceiling. So this plastic conduit or this polyvinyl chloride conduits are usually hidden or not exposed to the outside ceiling, unlike the metal conduits which are exposed outside the ceiling or outside the wall. Very good. Now the last type we have is the flexible PVC conduit. And this type of conduit is a plastic one, and it's made of the PVC also or the polyvinyl chloride. But at that case, it's not a rigid conduit, but it's a flexible conduit. Like that case here, you can see it's a flexible one, so it can be used in case of there are some pins in the path of the conduit, or there are some curvature shapes. And it's used also in case of the hidden conduits inside the wall, or inside the ceiling, or above the suspended ceiling. So this type is a hidden one which lays inside the concrete itself. Alright, so those are the main types of the conduits we have in the distribution system or in the electrical distribution system. Now we need to know how can we calculate the cross-sectional area of the conduit. Here we say that the conduit cross-sectional area depends on the cross-sectional area of the wires themselves, or it depends on the wires that are inserted or that are passing through the conduit. This is because the more number of wires inserted inside the conduit, the larger cross-sectional area we need. So if we need to calculate the conduit cross-sectional area, we calculate firstly the wire's cross-sectional area. And the rule says that we insert the wires inside the conduit, which occupies only 40% of the conduit cross-sectional area. So 40% of the conduit is filled with wires and 60% of the conduit is free of wires. And we allow the 60% of free area of the conduit of two reasons. The first one is that we make it easy for the wires to move through the conduit when we are inserting the wires inside the conduit, as if the conduit cross-sectional area is full with wires, it will be hard to pull the wires inside the conduit, so we need to make the installation process an easy one by allowing free area of the conduit cross-sectional area. And the second reason is that there is a heat produced when the electrical power is moving through the wires, so we need a free area to absorb this heat of the wires. So this 60% free of the conduit will make it easy for the heat absorption. While if the conduit is full with wires, there will be no free area, and it will make the wires and the conduit to be heated, which affects the conduit and the wires badly, and it may cause a problem in the wires installation due to the larger heat generated. Very good. Now we can rewrite this equation to P the summation of the area of each wire, and it's equal 0.4 of the conduit area. So it's pi over 4 of D1 square, which is the first wire diameter square, plus pi over 4 times the second wire diameter square, plus pi over 4 times the third wire diameter square, and so on until the last wire. And this is equal the right hand side, which is 0.4 times pi over 4 times the diameter of the conduit square, or the total diameter of the conduit square. And now we can cancel pi over 4 in the two terms on the left hand side and on the right hand side, and then we can rewrite this equation to P, or to have the conduit diameter to P the square root of the first wire diameter square plus the second wire diameter square plus the third wire diameter square, and so on until the last wire, over 0.4, or all of this term is divided over 0.4. So by that way we can detect the required conduit diameter by detecting each wire diameter. More than great. So that's about this tutorial at which we discussed the different types of the electrical conduits used in the electrical distribution system. Hope that's clear right now. Thank you for watching and see you next tutorials.